Welcome to the presentation on Work Package 6. I will give you a brief overview on what has happened since our last meeting. First, I want to talk about tasks 6.1 and 6.2. I will cover them both together as they are building upon each other. So it's the lifecycle assessment and the lifecycle costing. The objectives for these tasks are to determine the environmental impacts of the design for reuse building, as well as determine the costs and benefits of the DFR building. We are using lifecycle assessment methodology and lifecycle costing methodology, and by combining both, you can use them for different indicators, for example, resource or eco-efficiency assessment, and in particular, eco-efficiency combines costs and environmental perspectives. So that's something that we will do at the end of the work. We'll also look into the demolition processes in lifecycle assessment. So usually demolition processes were not really integrated in LCA or simply based on assumptions. The reason for that was that simply LCA data was missing for demolition processes. So we tried to at least start filling that gap by collecting data from demolition sites and converting them into LCA data. And currently we are preparing a publication on this. We have been talking about this aspect couple of times, in particular during the last meeting, so I will skip this. I will not talk about this in more detail this time. Okay, so given the developments in Work Package 2 and 3, we had to change up our system modeling, our system boundaries slightly. So beginning of this year, we've been in touch with Work Package 2 and Work Package 3 and also the RAM to figure this out. And so what we will now look at is only the ground floor and basically a shoebox. So we will look into the exterior walls and the floor cassettes, so the intermediate floor. That's basically it. But we, of course, given the focus of Work Package 2 and 3 on these different joints, these will be, of course, covered in the assessment in particular. So we will integrate the wall corner joints, the wall joints, but also, of course, the joints between the floor cassettes, the floor cassette to the exterior wall, as well as the exterior wall to the bottom concrete slab. So that is our system boundary. That is the kind of the building that we will determine. It is the real ground floor level for Villa Anneberg, so the exact length and width of the building, but kind of the with the top removed. The functional unit will now be 1 cubic meter of gross building volume. It directly connects to the new system and system boundary. Also, it is a value that is very typically used in the assessment of buildings, so it allows better comparability now, which is a nice side effect of this. Okay, if we look into the different life cycle stages, we've presented this also quite a couple of times now. So we will look into the production stage, the construction stage, as well as the end of life stage. So basically the entire building life cycle, excluding the use phase. The use phase is considered as being identical for the reference building as well as for the design for reuse building. So there are likely not to be many changes between those two buildings. So that's why you can exclude this stage. Of course, you could argue that design for reuse also makes repair and refurbishment work easier, which is probably true. but at least for now, we will not integrate these assumptions. Okay, so if we're converting the system into a LCA model, this is our reference system. So above here you have the life cycle stages as illustrated in the figure before. And then in blue you have the different processes that are considered. So for example, the wall manufacturing, the transportation of the wall elements to the construction site, the assembling on site, and then of course the demolition and so on. In orange you have the system boundary. As you can also see, the use phase is excluded from the system boundary. So this is here only for illustrating purposes. This is the design for reuse system. It is very similar, as you can see. Of course, the production line or the life cycle is, of course, more or less identical. Of course, there will be differences in the wall manufacturing. There will be difference in the assembly on site, the disassembly, the waste treatment, which will be covered by the data that we'll use. And then, of course, there will be, in the comparison, there will be differences, because in the design for reuse system, we will have the wall that is not going into incineration, but it will get a second life. Which means in this system, we will have the function of 2 walls provided, while in the reference system, there's only 1 wall that provides the service and the function of 1 wall element. But it generates more energy at the end of life because the entire wall is incinerated, whereas the wall number 1 is here recycled into the second one. So only a fraction of the energy is produced here at the end of this system. So while the second wall is missing in this in the reference system, we have to consider a second wall providing the same function. And here a lot of energy is missing in the comparison, so we have to add some energy generation. The overall idea is that you can only compare 2 systems that are providing the same functions to the market. For example, it has to provide the same amount of walls, it has to provide the same amount of energy. Otherwise, those systems would not be comparable. So now now we are filling all these processes with data. So that's usually the next step, collecting the inventory data. And of course, as we're focusing on the Dürram Villa Anneberg, we are requiring data directly from Dürram. What does data mean? It means, of course, cost data as well as quantity. So the number of materials, like the number of cubic meters of sawn timber that is used for 1 wall element, for example. So in general, we need the inventory data on the material consumption, the energy consumption, different devices used, tools, machines, and so on, as well as labor. Labor is, of course, one of the driving factors in the cost analysis. So this is not, of course, looked at in the life cycle assessment, but this is looked at, of course, in the cost assessment. I think 1 or 2 weeks ago we received data from Dürram, and almost everything that we have asked for is provided. So thank you very much, Dürram, and in particular Anders, for providing us with the data. It's really helpful, and it looks really good. So we can now start modeling. As far as we know, most of the data is real data, but only some of it is based on assumptions. So in particular, of course, in the design for reuse system, some data cannot be taken directly from the manufacturing plant, of course, but has to be assumed based on the experiences from the engineers. But that is totally fine, of course. But that is where the data comes from. Additionally, we will most likely combine that data with own calculations where the RAM wasn't able to provide us with data. We will use, for example, the building plans and combining with literature data to fill it up. Regarding the costs, we will use the RAM data, but we will also use some average data from, for example, the German construction cost index, as well as reference prices from Germany. So, for example, the diesel price, for example, can be taken, of course, average data from Germany, but also from Sweden. And that, of course, doesn't have to be provided necessarily from Durham, but that is easily to collect on your own. So this is basically where we are right now. We have received all the data from Durham and will now be able to start modeling. Maybe some of you are still struggling understanding what modeling in the sense of life cycle assessment actually means. So I try to illustrate this. Maybe it helps understanding. This is just one process. This is the wall manufacturing process. And of course, for the wall manufacturing, you need certain materials and energies. You need machines, and these are just some input values. And this is what we're working with: 2.5 cubic meter of sawn wood, adhesives, foil, and so on. These are the input materials, and then you have certain number of outputs. Of course, you have 1 cubic meter of wall. You usually have some waste materials, so can be sawdust, can be wastewater, and so on. And you have some emissions. So, for example, CO2 emissions, some nitrogenous emissions, and so on. The 1 cubic meter of wall is the valuable output, so that is used as input in the next downstream process, which is the transportation to site, while all the waste materials are sent to a waste treatment process and the emissions are used in the impact assessment. So, for example, the CO2 emissions, they will be covered by the global warming potential indicator for the overall assessment. So this is what modeling means. So we're taking the RAM's data as input data and maybe also partially output data, and then fill these into the different processes. And this then overall compiles the entire model. So that's our next step, implementing the considered system boundaries as well as the data in our LCA software in order then to do the impact assessment calculations. Then we have the task 6.3, which is the life cycle assessment of recovered wood products. We have presented this in detail for the last meeting. I will not go into detail and present you all of the systems again, so you please go back to the earlier videos on task 6.3 where we are describing this in more detail. But the idea is to compare the environmental impacts of CLT from fresh timber with CLT from recovered timber. We want to identify the differences between the manufacturing processes and identify driving factors, in particular, of course, in the production of CLT from recovered timber. We will compare the CLT from recovered timber first with CLT from fresh timber. That's what's written up here. we will compare it additionally with alternative waste treatment options, and we will most likely compare it with functionally equivalent non-timber products. This is actually conducted in application, so to say. So we're not looking into CLT only, but or CLT and the reference product, but we are looking into CLT as wall element or within a wall compared to, for example, a brick wall. But then, of course, it's not only the bricks, but it's also additional materials in the combination to provide the same wall functions as the CLT wall would. So that's an interesting approach here, because we're not looking into the product itself, but into the application of the product. As said in the past, this is covered by a master's thesis. He's doing quite a good work. Unfortunately, it's still not yet complete. I hoped that he would be finished by now, but well, he's not. He's doing a good job, but not very efficient. So we still have to wait. In any case, of course, we've made some progress. We have received data from Galway and Madrid. So thank you to Catriona and Daniel for providing us with very helpful data on the CLT manufacturing from recovered timber compared to primary timber. And so that is all available, or the data is available, and we have integrated the data into our systems that are already modeled. So currently the master student is doing the scenario and parameter calculations. So he runs different scenarios right now, and for the impact assessment. Yeah, so we hope that we will have the results ready within the next couple of weeks. Okay, and then task 6.4, you remember the documentation guideline. You all have, or those who are interested, have heard the presentation from our master student Nora, and you've also received an English summary of her work that has been provided to all of you. So most of the work is done. We're currently, or we will be working on a more evolved version of this guideline over the summer, but yeah, most of it is done. So far about the progress in work package 6. See you soon. Thank you.